Hello, so this is probably going to be a two-part series for the final topic in probability, and it's just a combination of the addition rule that we discussed and basically mutually exclusive events and independent events, so the multiplication rule and the addition rule together. But before we go there, I wanted to show you another solution to 16a part 2, and to do so, we will look at this diagram here. All right, so this represents your possible rolls. So 1 means you roll a 1 first, and then you roll a 1 on the second dice. So roll 1 on the first dice, 2 on the second dice. So this represents all the possible roll combinations that you can have, right? And basically, we want to think of possible combinations in two rolls that take us back to the home square. So if you remember, we have a red square on 2, on 7, and on 12. And 12 is the maximum number that we can reach in two rolls, right? All right. So 6 and 6, that is going to get me to 12, and 12 is a bad square. It's a red square, right? So that's one possible, which I have highlighted. 1, 1, we get to 2. 2 is a red square, right? 1, 6 takes me to 7 is a red square. 3, 4 takes me to 7 is a red square. 4, 3 takes me to 7 is a red square. 5, 2, and 6, 1 all take me to 7, which are red squares. Now, most of these make sense, right? Now, two combinations here that you probably think won't make sense, and that is 2, 2. 2, 2 gives me a 4, so why does this take me back to the home square? Let's think about this here. You roll a 2, you get back here, you go to the start. You roll a 2 again, you get to this square, you go back to the start. So that is why 2, 2 works as a combination. So why not 2, 5? That gives me a 7, right? Well, why doesn't 2, 5 work? Well, if you get 2 on the first roll, you go back to the start. And then if you get 5, you are here, right? So you are not at the start after 2 rolls. So that's why that square does not work. So you have 36 possibilities. And out of 36, you have 1, 2, 3, 4, 5, 6, 7, 8 favorable outcomes. So that is why we got 8 over 36. And the other way of thinking was that, well, the other way of thinking that I used to solve the question was, well, how many ways I can get to this square? Well, there are two ways. Either I roll 1 and a 1, right, which has the probability of this. Either I roll 2 and a 2, which has a probability of this. Either I roll 6 and a 6 to get here, right, which has a probability of 1 over 6 squared. And then I am safe on my first roll. And then I roll a number that takes me to this red square, right? So if I get 6 on my first roll, I need to roll a 1, I need to roll a 2, I need to roll a 3, I need to roll a 4 for this one, and I need to roll a 5 for this one, right? All right. So basically, for every safe number I have rolled, there is one number that will take me to the second red square. And I don't need to worry about going to this one because I've already counted it in my possibilities. So this one will also give me 8 over 36. That is 2 over 9. So there are 5 safe squares, and then one roll can take me to this red square. All right. So that is how you can approach question 16 part A, part 2. And now we are going to move on. So this one is a combination of most topics that we have discussed in this chapter. So basically, not a lot of theory to do here, just we're going to go through the questions. All right, Y and Z are independent events. So what does independent event mean? By definition, Y and Z, if they are independent, then their intersection is Py multiplied by Pz. That is the formal definition of independence. So you just multiply these two. 0.7 times 0.9, and that is 0.79 63, right? 0.63 is going to be your answer. All right, so that is how you do one. Two independent events are M and N. All right, so by definition of independence, Pm and N happening together is Pm times Pn. So this works for independent events, remember that. So we know Pm intersect N. So this is 0.21. And Pm is just 0.75. And we need to find Pn. And Pn we can get by simply rearranging this equation. This is 0.21 divided by 0.75 which is 0.28. And we are done. Independent events S and T are such that PS is equal to 0.4 PT naught. So PT is going to be 1 minus PT naught, right? And this is something we have discussed. So that is 0.8. 1 minus 0.2 is going to give me 0.8. All right, find PS intersect T. Well, this is just PS times PT. It's just the product, right? So what is PS? PS is 0.4 and PT is 0.8. We have calculated that here. So if you multiply them together for this, you're going to get 0.32. All right. And we need to find PS naught intersect PT. And because they are independent, right? So this is PS naught times PT. And what is PS naught? Well, that is what just 1 minus PS times PT. All right. So what is 1 minus PS? Well, that is 1 minus 0.4 times PT. PT, we calculated to be 0.8. All right. So 0.6 times 0.8, that gives me 0.48. All right, so we are done with 3. So for B is 0.48, for A is 0.32. All right, so I hope this was clear. I'm going to erase things. We are done with 1, 2, and 3. All right. 1, 2, and 3. All right, so 4. A, B, and C are independent events, and it is given that A intersect B is this, B intersect this is this. Okay. All right. Express A in terms of, so AI, right? So in terms of PB, so I know PA intersect B is PA times PB. So PA is just going to be PA intersect B divided by PB. So PA intersect B is just 0.35 divided by PB. So that is what they want. We don't know what PB is. We just want to express. And I'll leave this to you. It's fairly similar. So it's going to be PA intersect C is equal to PA times PC. And then PA is just PA intersect C, which is 0.4 divided by PC. That is it. That is what they want. All right. Use your answers to part A to find what is PB. All right. So we need to solve for PB, right? So let's see. All right. So I think we're going to need to do a bit of algebra here. So I know two expressions for PA. So we can set these to be equal. So I know 0.35 divided by PB should be, this expression is PA, should be equal to this expression. All right, so I know I'm going to say that is equation 1. I have this information as well, right? Because they are independent, PB intersect C is equal to 0.56, right? It's just going to be PB times PC. All right. So these are the pieces of information that I have. And from this, I know that PC is just 0.56 divided by PB. And I can substitute this information here. So 0.35 divided by PB is equal to 0.4, and PC is 0.56 divided by PB. All right. If you rearrange this, you are going to get 0.35 times 0.56. So I'm going to leave the rearranging to you, but this is the final expression that you are going to get. PB squared. This will go in the numerator. You multiply this here. This also goes into the numerator, right? So you get this expression. So from this, if you calculate PB, PB is going to be the square root of 0.35 times 0.56 divided by 0.4. And that is 0.56 divided by 0.4. And then if you take the square root, that gives you 0.7. All right, so you know the value of PB. It is 0.7. All right. So if I know PB, I know PA, right? PA is just 0.35 divided by 0.7. And this is just 1 over 2, right? This is just 0.5. All right. So what is PA naught? This is equal to P1 minus PA is equal to 1 minus 0.5 is equal to 0.5. All right. Now what is this? Because they are independent events again, you can write this as PB naught times PC naught, right? If A and B are independent, A, B, C are independent, the complement of these events are also independent. All right. So what is PB? Well, PB naught is 1 minus PB, and what is PC naught? 1 minus PC. Let's find PC first, right? Because PC is this expression. So PC, we are going to get 0.56 divided by PB was 0.7. So 0.56 divided by 0.7, that is 0.8. All right. So 1 minus PB, 1 minus 0.7 is 0.3. 1 minus PC, 1 minus 0.8 is 0.2. So we get 0.06 as our final answer. All right. So you get 0.06, right? 0.06 was your final answer. All right. So I hope this was clear. I'm going to erase things. I hope that is okay. And then question 5. So I'm going to draw the Venn diagram here. In a class of 26 children, so basically, we have two situations, right? Some students attend the bio class, some students attend math class, some students attend probably both. All right. So 19 attend biology classes, 13 attend math classes, and 6 attend both. So I'm going to start with the inside. 6 attend both, right? And then I need 13 here, because 13 plus 6 gives me total 19 students in my biology class, and then 6 plus, I believe, 6 plus 7 is going to give me 13 students who attend the math class. And if I add these three together, so I have 2 students, right, who don't attend either math or bio class, because 13 plus 6 plus 7 is 26. And I have 28 students, right? I have 28 children. So 2 students don't take neither bio nor math. All right. One child is chosen at random from the class. Event B is a child who attends biology class is chosen. So let's find the probability of B. Probability of B is we have 19 students who take bio class out of 28, right? What is probability M? Well, that is 13 students out of 28 that attend math classes. All right. So basically illustrate the data in an appropriate table or diagram. That just means this Venn diagram. That just means this Venn diagram. All right. And it says, are events B and M independent? So if we need to check for independence, we need to check for this equality. What does this mean? Well, this is the probability that a student takes bio and math classes. So that is the 6 students here. So this is 6 over 28. And what is this? 19 over 28 times 13 over 28. So are these two equal? No, I think they are not equal. So that is why they are not independent. All right, that is all that you need to do. And this is the diagram. This is the Venn diagram. All right. So we have another Venn diagram here. AT was asked whether they regularly read or regularly watch a movie. It's given in the Venn diagram. We are selecting one child. So basically we have 2 events. Probability that a child reads and the probability that a child regularly watches a movie. If they are independent, then this will be satisfied. what is the probability that a child reads? It's 32 over 80. Right? 32 over 80 children. What is the probability that they read and watch movies? 20 over 80. And then probability that they watch movies regularly is 50 over 80. All right, let's try to simplify this. My left hand side simplifies to 1 over 4. My right hand side, 32 times 50, simplifies to 1600 over 6400, right? Yep. And this is also, right hand side is also 1 over 4. So therefore they are independent, because this is satisfied. Sorry about it. This is multiplies. All right. So they are independent because it satisfies the formal definition of independence. All right. 2 fair 4-sided die are rolled, both with faces marked this. All right. So event A is so basically, let me just draw the possible outcomes. 1, 2, 3, and 4. And then I have 1, 2, 3, and 4. So I can draw 1, 1, 1, 2, 1, 3, and 1, 4. I can draw 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, and 4, 1, 4, 2, 4, 3, and 4, 4. So these are all the possible outcomes, right? The sum of the numbers obtained is a prime number. Let's see. So let's do the probability. Right? Okay. So probability of A, that the sum is a prime number. Let's look for it. 1 plus 1 is prime. 2. 1 plus 2 is prime. That's 3. This is not prime. 1 plus 4 is prime. And 4 plus 1 is prime. Right? 2 plus 1 is prime. 3 plus 1 is not prime. 4 plus 2, 4 is not prime. 6 is not prime. 4 plus 3 is 7 is prime, right? 4 plus 4 is 8, 8 is not prime. 3 plus 4, 7 is prime. 3 plus 3 is 6, 6 is not prime. 3 plus 2 is prime. And 2 plus 3 is prime, right? These give me 5 along this diagonal. So 5 is prime. This gives me 7, 7 is prime. This gives me 3, 3 is prime. This gives me 2, 2 is prime. Everything else does not give me a prime number. Yep. All right. So PA is equal to, I have 16 possible outcomes, 4 times 4. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 highlighted. So 9 over 16 is PA. What is PB? The product of the numbers obtained is an even number, right? So which are the numbers that satisfy this? These two. Everything here is even. And these two, right? So basically both numbers can't be odd. I need at least one even number. So I have 2 plus 2 is 4 plus 8. So I have 12 such numbers. So if you count everything that I've placed orange line under, that you're going to get 12 over 16. And P, A intersect B. So basically I need to count which have a yellow, so which are circled in yellow, and which have a pink underline, right? Because these are going to be the ones that satisfied both. So this and this, 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 and this. So basically I need yellow plus a line. So how many numbers did I circle in blue? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 over 16. All right. And they want me to find it in the simplest form. So 9 over 16, they are co-prime, so I can't do anything about it. This is 3 over 4, and this is 1 over 2. All right. So that is solution to A. Determine with justification whether events A and B are independent. For independence, we just do this, right? We just check this. Is equal to PA times PB. All right. So PA intersect B, that is half, should equal to what is PA? PA is 9 over 16 times 3 over 4. So 9 3s are 27 over 64. They are not equal. So not independent. All right. Give a reason why events A and B are not mutually exclusive. Why? Because P A intersect B does not equal to 0. That is why they are not mutually exclusive. Therefore, not mutually exclusive. Remember, if something is mutually exclusive, then their intersection has to be 0, right? So this is from topic 1, so they are not mutually exclusive. All right. So we are done with 7. And if you are happy with the solution, I'm going to erase it and move on to 8. All right. So 2 ordinary fair die are rolled. So basically, again, just list the outcomes. And basically 1, 1, 1, 2. I'm just going to list them here. I'm not going to draw a table. 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. If it's something listable, just list it because that's going to make your life easier. Four, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4. All right. So event X is the product of the 2 numbers obtained is odd. All right. So basically, let's look for odd products. So it has to be both numbers odd, right? You can't have an even number. So just look for numbers where both of the numbers are odd. So their product is going to be odd, right? So it's going to be all of these numbers. Oh, sorry, not that one. Not that one as well. 5, 3 and 5, 5. Everything else, the product you're going to see is going to be even. So you have 9 out of 36, right? Probability of X is 1 over 4, basically, which is 9 over 36. All right. The sum of the 2 numbers obtained is a multiple of 3. So sum has to be a multiple of 3. So I'm just going to underline if it's true, right? 1 plus 2 is a multiple of 3. 1 plus 5 is a multiple of 3. The rest are not, right? 2 plus 1, multiple of 3. This gives me 4, 5. 2 plus 4 is a multiple of 3. Nothing else, right? I think 3 plus 3 gives me 6 is a multiple of 3. 3 plus 6 gives me 9 is a multiple of 3. The rest are not multiples of 3. 3, 6. So basically multiples of 3. I'm looking for 3, 6, 9, 12, something like that. So 6 plus 6, 12, right? Immediately. So 7, 8, 9 works. 12 works. All right. 5 plus 4 works because that is 9. And 5 plus 1 is 6, right? So these two numbers work. 4 plus 5 works because that is 9. And 4 plus 2 works because that is 6. And I think that is all, right? So you have 2 pairs for every line. So basically the probability is going to be 2 pairs per line. You have 6 lines, so that is 12 over 36. That is 1 over 3. All right. And if they are independent, so let's look for what is Px intersect y. Basically, it's going to be everything in yellow highlighted plus, so that satisfy both, right? So yellow highlighted plus I have a line underneath. Is there anything else? No, only 3 numbers. So this gives me 3 out of 36. All right. Are they independent? So if Px intersect y is equal to Px times Py. So my left-hand side is 3 over 36. 3 over 36, if you think about it, is 1 over 12. Px is 1 over 4. Py is 1 over 3, right? And if you evaluate, that is 1 over 12. So yes, they are independent. All right. Are events x and y mutually exclusive? No. They are not mutually exclusive because p, x, and y does not equal to 0. All right. And we are done with 8. So basically, and if 8-sided die, basically it's an 8 by 8 grid, right? We roll it twice. So you can list them as well, right? Basically, we have 8 possibilities. So you 1, 2, 3, you list it until 8, and you can just pair them up. So just do this, but for an 8-sided die. That's fairly easy, right? So you can do 1, 1, 1, 2, 1, 3, right? 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. And then you just repeat. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, right? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8. All right. 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7, and 7, 8. And finally, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 8. And each possibility, each outcome is equally likely, right? All right. So event V is one of the scores is 4 less than the other score. Exactly 4 less than the other scores. Basically, that means the difference is 4. Right? So PV, difference of 4. Is there any pair here that has a difference of 4? So I'm going to highlight it in yellow, right? This has a difference of 4. 5 minus 1 is 4. Everything else, not a difference of 4, right? 6 minus 2, difference of 4. Let's see. 2 numbers with a difference of 4. 7 and 3, difference of 4, right? I don't think anything else has a difference. 2, 3, 4, 5. No. This has a difference of 4. Nothing else has a difference of 4, I believe. Right? And then basically 5, 1. So just these numbers again. 6, 2, 7, 3, and 8, 4. So basically, you just find all the pairs that have a difference of 4. So you have 8 such pairs, right? 8 over 64. So that is just 1 over 8. PV, sorry, that is PV, is 1 over 8. So PV is 1 over 8, or it was 8 over 64, right? All right. The product of the scores is less than 13. Nothing in row 1, right? Nothing in row 1 will satisfy that. Sorry, is less than 13. So everything in row 1 will satisfy that. Everything in row 1 works because the product is less than 13. Everything in row 1 works. 2, 1 is 2, 2, 2 is a 4, 2, 3 is a 6, 2, 4 is a 8, 2, 5 is a 10, 2, 6 is a 12. Up until this, we are okay. 2, 7 is a 14, so we don't want that. 3, 1 is 3, 3 is a 6, 3, 3 is a 9, 3, 4 is a 12. That's it. 4, 1 is 4, 4, 2 is a 8, 4, 3 is a 12. That's it. 5, 1 is a 5, 5, 2 is a 10. Stop. Right? 6, 1, 6, 6, 2 is a 12. Stop. We don't need to go more than 13. 7, 1 is 7. Nothing more. 8, 1 is 8. Nothing more. So how many lines did we draw? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right. So PW is 27 over 64. So are they independent? Well, let's see. PV intersect W. Let's find it out. How many are yellow and underlined? Yellow and underlined. This is yellow and underlined. This is yellow and underlined. This is yellow and underlined. And this is yellow and underlined. So that is just 4 over 64, which is just 1 over 16, right? All right. basically the question is PV intersect W equal to PV times PW? And PV intersect 1 over 16, is it equal to 1 over 8 times 1 over 16, right? Sorry, 8 times 27 over 64. And you will find that these are not equal. I don't think they are equal. So they are not independent. All right, we are done. Now the next few questions, we're going to deal with data, the skills that we haven't gotten yet because we haven't discussed data collection, but I'm going to guide you through in another video for these, and I think this is it for this chapter. I might make a video for the last 3 questions. Maybe I will not. I might delay it for a while, but we are probably going to discuss coordinate geometry next. All right, that is it.